PixInsight because we're going to be running deconvolution. This is our color image that we've been working on so far, and we need to pull up our luminosity image. What we're going to need in order to run deconvolution, we're going to need an image that represents our point square function. Now we could use some that have been already programmed by PI, and you can change the shapes and every aspect of the star you can take if you knew what your average star looked like, or you can just gamble and use one of these stars. I would prefer to create a star, a point spread function image that is an average of all of my stars. Keep in mind I had to drizzle, which meant that I took the stars that I actually captured and I upsampled them 2 times. So I would rather have software help me to average the star size and shape that represents this image. So let's kind of set decon aside for a minute. We're going to need 2 masks, and we're going to need a point spread image. So in order to do that, there's 2 ways of doing that. You can use the dynamic point spread function, and this is kind of a long way of doing it, but it's a very effective way. And you can also select script, render, and go down to point spread function. Now I've already done this one. If you click on evaluate, then it'll start evaluating these stars, but it takes me about, when I have this many stars, it runs about 5 minutes in order to create the star. So I've already done that, and I already have created that star. I think there it is, and that star is right here. I'm going to change that to capital PFS. Okay. Well, it says it's being used, but I know it's not. That's fine. And I'm going to put that down here. Let's put that back. And the way you create your own using the dynamic point spread function is you go to process, all processes, and go down to dynamic point spread function. That's this. And again, I save these process icons because I use them all the time. And then I'm going to delete this. That was chosen by accident. And when I tried to delete it, wouldn't let me. We'll close it out, and we're going to bring it back up again. Okay. What you do is you click on your stars, and you need to select 20. And for example, let's click on this one and make a note that it is a Gaussian image, and then the 2 things that you need to pay attention to are whether it's Gaussian or Moffat, and column A. Column A tells you the luminosity level of your image. Between 2 and 8 is ideal. If you go to 1 or over, it's saturated. If you go under 2, the star may be too faint to be helpful in creating an average. So let's see if we can't find 20 stars. We have 2. That's going to work. That's going to work. That's going to, nope, this one isn't going to work. It's Moffat, so we're going to delete that. You want them all to be the same. Either Moffat or Gaussian. And you want the values to be above 2 and below 8.5 works. Moffat, delete. Moffat, delete. Moffat, delete. Now if you have more Moffat than you have Gaussian, then you can use Moffat. That works. That works. So we have 14. That works. That works. That works. That works. That works. That doesn't. That doesn't. That doesn't. That doesn't. That doesn't. That does. That doesn't. That doesn't. I think that's 2 stars. That does. That does. That doesn't. I think we have enough. And so once we have our stars, then we go up to click on one. Control All works as well. I want to double check the A column that we don't have any that are not going to qualify. Okay, and once you have them selected, go over here to, it looks like a camera, and click on that. You can now close this out, and that is the average star PSF. So we've got now one that we did using Hartmut-Bormann's PSF image script, and we have one where we used the dynamic PSF to create our own. So now what we need to do is to bring up deconvolution, and again, as a reminder, we're preparing this image because when we get towards the end of our processing, and I'm talking about processing our color image, when we get finished processing our color image, we're going to apply this luminosity image. We're going to combine it with our color image. So we want to have our detail, we want to have our contrast, we want to have everything, the sharp looking part of the image we want sharp, the smooth part we want smooth. We want to cover, we don't want any of the oversaturated areas blown out. We want a good luminosity layer because it doesn't really matter so much about the color. When we apply this, it'll kind of straighten things out. So we will apply noise to the final noise reduction to the final image, but so far we're just working now on this, preparing this loom layer right here to be used later. And after we do this, we're going to stretch it. Keep in mind, this image has not been stretched yet. It's still in the linear state, and that's what it's very important that when you run Decon, you run it on an image that hasn't been stretched. Now, we're going to take our luminosity mask, which has been stretched, and we're going to apply it by dragging. Just take the title, hold down your left mouse and click and drag it over until you see a box. See the box, and then you drop it and this will turn kind of brown, reddish brown. The mask has been applied. If you go up to mask, you can click on show mask, and you can see where the mask has been applied. Excuse me. Don't worry, you can't catch COVID from me. Okay. Now we're not going to show the mask, but we still have the mask applied. At all times, when this has a color similar to this red or brown, there is a mask applied. Okay, so we have a star mask applied, and a luminosity mask. Now, what we want to do is we want to apply a star mask, and remember we created one a little earlier on. And this will be our local D-ringing support image. So it's already been selected by default because I always have that. And it's a process that I've saved with my process icon. Now, I run anywhere between 30 and 70 iterations of regularized Richardson Lucy. I don't change anything up here because we're going to use an external point spread function, and I think I'm going to pick the one that I just did in the dynamic PSF. So we're going to pick the big one in the capital. Alright, that'll be our point spread function average star that will be used and applied here when we start tweaking through deconvolution. I'm going to leave the local amount on 70, although that's subject to change, but the one slider that I use the most will be this global dark slider. D-ringing needs to be checked, and I don't fool with anything down here. High range, low range, I leave alone. The noise model is Gaussian. That stays the same. Even though when you're doing this you have you may be using Moffat, that doesn't have anything to do with this. So under wavelets we have 5 layers. That doesn't change. So I don't change anything down here, or I have not changed anything down here, and I really don't know what effect it would have if I did. So I'm going to just concentrate on global dark. Now, unfortunately, there's no preview, real-time preview. So what I'm going to do is I'm going to go up here, and I'm going to, at the top here, and I'm going to take this icon, which is going to be to create a preview, and I'm going to create a preview. Let's say I want some stars in it, and I want some nebulosity, which is anywhere and everywhere in this image. Let's go about right here, and it's a small preview, but I want to kind of zoom in onto this and see what effect this is going to have on my image when I run this decon. So I have it set pretty high here at 0.045, but let's go ahead and run it and see with 50 iterations what it looks like. I've already gotten a couple warnings. I've gotten some more. So yeah, you can see this is butchering it up somewhat. Let me go to the before and after. This was before, and then by running decon we've added some artifacts and actually some noise to the image, so that isn't going to work. So let's drop this down to, let's say, 350 and try that. Already I have some issues, so I know this is going to be not as bad, but not good. So let's go back to our before and after. Okay, I'm getting it's just a little too much for me. Before, I mean after, before, after, before, after. The stars are looking better. If you look at, just follow these stars, and they're looking better. This is before, and this is after. It's kind of tightening things up. And we don't have any ringing that I can see. I'm looking all over this right now. But I'm going to lower this down to 300. And I'm going to go up to 70 iterations and see what happens. That's too many iterations. So we can check this and see the before and after. That's before, after. Before, after, before, after. All right, we're going to go back to, let's try 40 iterations. And that's a little better. But I'm going to go down to 250 and back up to 50 iterations. And again, this is, I'm going to create another area where I got another preview where I've got some darker skies in here. And let's see if the ringing shows up. Oh, this isn't going to work. That's what I was afraid of. So had I ran that on the other side, I would have been in a mess. Let's go back up to, actually I made a boo-boo, 0.030, 0.0250. That was the problem. This is going to work. I think I found the, yeah, this is going to be much better. Okay, there's after, and let's go to before. Before, after, before, after, before. See how it's tightening up the stars without a noticeable effect on the background? Great. All right, we'll go back to our layer and let's run it. It's going to take it probably every bit of, to run 50 iterations, every bit of, we're just now running one iteration. So it's going to take it probably 10 minutes to run all of this, and I will put you on pause and be back. Okay, I think we have a winner. So I'm going to get rid of the two previews and go to preview, delete all, remove the mask, and we're going to take a closer look at our Yeah, it's looking good. We may run TVG denoise on it, but right now we're going to put the luminance layer away. We're going to put the luminance mask away and deconvolution away, as we have finished that. Okay, folks, have a great rest of the day, and I'll see you for in the next video, where we will take the color image and we will run the histogram transformation and take it from a a state of being changes are pretty much non-destructive in a linear state to a stage where we are going to stretch it and prepare it for some final moves, so our final processes. So with that being said, I'll catch you later.